Hello everyone, welcome to the another very important session in which we will be discussing some more important questions and the concepts and how you can work on these questions in quite simple and easy manner even in less time. That's what we are going to talk about today in this session. So I hope it will be helping you all to take your preparation to a very good level and will be helping you to understand the type of questions you can have in your upcoming exams. So, in all these ways, like you will be able to have a better preparation after attending this session. So, we are going to continue the discussion, but before that, I'm going to talk about some important things and then we will be continuing the discussion about the important questions and the concepts in this session today. So, the first slide you can see here on the screen right now, it is related to the latest offer which is going on right now on Unacademy Subscription, and with the help of this offer, by using and by applying the code that is Anjali A Live, that is the referral code as it has been mentioned here on the screen. By using and by applying this code, you will be able to get the discount in the total subscription amount. Okay, and how much discount you will get? So there will be 20% price drop on iconic subscriptions. So all details about the offer have been mentioned here, okay, which will be helping you to get the discount and even to take the subscription. So here we are gonna have more details about the Unacademy Plus, Iconic and the Lite subscription. With the help of this slide, you will get to know that what is the difference between the Plus, Iconic and the Lite subscription, so that depending on whatever you are finding more beneficial for you, you can take that subscription and you will be able to start your preparation under the guidance of top educators too. Even now, the notes are available on the Unacademy Learning app. So if you will be taking the Plus or the Iconic subscription, you will be able to check out these important notes as well. Okay, I'm just gonna check everything here, like everything is all right. Yeah, that is fine. Let's go ahead. So this way, guys, everything is gonna be so much helpful for you to take your preparation to the next level. Like the benefits you are getting if you are taking the Plus subscription, the Iconic subscription and the Lite subscription, and the discount you are gonna get if you will take the subscription by using and by applying the code that is Anjali A Live, as even mentioned here on this slide. Okay, now here we are having the slides regarding the Plus, Iconic and the Lite subscription separately as well. The offer slide once again for everyone, those who have not got to know in the starting. And here we are gonna have few more slides. This is about the Unacademy Learning app. This is about the session. This is something about me. This is about the community feature we are gonna have on Unacademy, which will be helping you to get the latest updates and to know about the important information related to whatever new courses are there and whatever latest updates are there. So everything you will get to know with this. Now guys, let's talk about the next thing, that is the questions we are going to consider here. So today's session discussion will be related to the important questions and the concepts, and everything will be completely related to your CSIR NET and the GATE Physics exam. So whatever you can expect in your exam, from what section you can have the questions in the exam, so all that we are going to take care of, and that's how we will be taking the questions here. We will be having more sessions, okay, here on UL Live CSIR UGC NET. So if you don't want to miss these sessions, you can take the subscription. Now I'll try to include most of the questions here which are just based on trick. So here is our first question, and these questions will be from different subjects too. So if the perturbation that is going to be h dash is equal to ax, okay, and as you will see the question statement and you think like you can answer it quickly, you can just directly mention your answer in the comments, where a is a constant is added to the infinite square potential and the potential expression is even given to us, that is Vx is equal to 0 and infinity. 0 for x lying between 0 to pi, and otherwise its value is what? It's going to be infinity, right? So in this situation, the correction to the ground state energy to first order in A is options are A pi over 2. It seems to be more dark. There's a pen. Okay, A pi. Option C is A pi over 4. And option D is A pi over root 2. Try it now and let me know if in case there is any doubt you will have. And if anybody is there who already knows like how to find the answer for this one, what will be the right answer, just mention it in the comments. I'm gonna look at your answer whether it's correct or no. And otherwise, just in some time, I will be starting the discussion for everyone, like those who don't know what to do in such a situation or such type of questions. So we will be talking about it. So the question says, the perturbation applied to the system is this. Now you can see it is a function of x, right? What you will get from here, you are gonna know it is a variable perturbation. So when you are gonna know, oh, it's a variable perturbation, what next? The next thing is that you have to consider the average value of the perturbation applied to the system. Now, when I say average value, the expectation value, the mean value, all that has the same meaning, right? So, in that case, you have to find the average value of the perturbation applied to the system, and that will give you the correction to the ground state energy to the first order in A, right? So, when you are going to consider it, what will happen in this case? A is a constant, you don't have to do anything with this, but x is a variable, so you have to find the expectation value of x. Now what it will give you, the initial value and the final value, just add them and the divided by 2, because you know whenever we find the average of something, what we do, if there are 4 such numbers, we add them and divide by 4, right? Same way, if we are just having the extreme values right now, that is 0 and pi, just add them, divide by 2, that will give you the average value here. So it is going to be A pi over 2, and this is your first order correction to the ground state energy. That's it, you got the answer. That is option A, which is the correct answer. So this is the way, if there is a variable perturbation applied to any system, like it's a function of x, I have shown you here. Other than that, if you have to find the ground state, first order correction to the ground state energy in such a situation, so that's how you can proceed and you can get your answer. This is one of the tricks we are gonna have. Let's go over the next part. Even that's a trick. Like you may find some tricks easy, some tricks like quite new to you. So we are having different kind of, right? So the next one is, and if you know it and you can answer the question, just mention it in the comments quickly. A particle in one dimension moves under the influence of a potential which is, influence of is gonna be together. In potential, Vx is equal to Ax to the power 6, where A is a real constant. For large n, the quantized energy level, En depends on n as. Depends on n as what? The option says n cube proportional to n cube, n to the power 4 by 3, n to the power 6 by 5, and to the power 3 by 2. Now if you know the answer, just mention it in the comments. What is the right answer according to you? And if you don't know it, I will let you know then. Don't worry. Just giving you some time. If you know the answer, guys, just mention it in the comments. Otherwise, I'm gonna talk about it. What is the right answer? What is the right answer? What is the right answer? Okay, let me just give you the trick here as well. So basically, guys, in this situation, what will happen? In this situation, you are just simply going to consider the energy En as per the WKB approximation method will be proportional to n to the power 2 nu over nu plus 2. And what is this nu here? So nu is if v is proportional to x to the power nu. Nu means the power of x. So what is that here in this situation? It's 6, right? So you will just plug in 6 at place of nu. So it will give you 2 times 6 and 6 plus 2. That is going to be 12 over 8 and that is going to be 3 over 2, right? So your right answer should be option D. So this is the trick. Nth state energy will be proportional to n to the power 2 nu over nu plus 2. Okay, this is the WKB approximation method which gives you this expression in the condition and helps you to get the nth state energy dependency on the n. The nth state energy dependency directly on n and how it depends on the nu means the power of x, right? So this is important and based on it we had so many questions in the previous years. So if you're the one who was not familiar with it, you can prepare it now. It will be helping you a lot. Let me just give you the another one, guys. Let's even include this. It's quite interesting because it includes 3 different concepts here. Let psi and Lm denote the eigenfunctions eigenfunction of a Hamiltonian for a spherically symmetric potential which is VR. The wave function psi which is equal to 1 over 4 psi 2 1 0 plus root 5 psi 2 1 minus 1 plus root 10 psi 2 1 1 is an eigenfunction only of option says H, L square and Lz. H and Lz. H and L square. L square and LZ. Try it now and let me know as you will get it done. If you know the right answer, just mention it in the comments. If you don't know, I will be helping you to work on it or to understand like what will be your right answer and how you will be doing it. So here you have to consider that psi is the eigenfunction of which of these h, which is Hamiltonian, L square, that is going to be the angular momentum quantum number. Like, so you can just consider L as the square root L into L plus 1 h cut, right? So when you operate it on something like psi or something like that, you get this. Now the next thing is, if you consider L square here, you will have just the square root get removed and the h square will be there, right? Other than that, LZ gives you what? If psi NLM is there, so it will give you MH okay, and psi NLM remains as it is. Same way for the above part, you can also show the suffix psi NLM, right? So it was just to let you know, okay, this is the L. These are operators. Now, if we are gonna talk about, this is the angular momentum, okay, operator, you can say, in quantum mechanics. Now, if we are going to talk about the eigenfunction, so when you can say it's the eigenfunction, when your all terms will be there even after operating the particular operator like the Hamiltonian, L square or LZ on the given function. So in that situation, what will happen? It will be helping you this way. See, you know that Hamiltonian depends on n, because if you will recall, the Hamiltonian means the energy expression of hydrogen atom. You know it's dependent on n square, like in the denominator you had the n square in that expression. So in this particular situation, if you will see the n value in all the terms, it's gonna be same, right? So when it is gonna be same, in that case, your particular psi expression is the eigenfunction of what? Hamiltonian. Then for L square is going to be what? L times L plus 1 h square. So you can see L is also going to be equal to what? 1, right? So this is how you are just going to consider it. And Lz is equal to what? Mh cut. So mh cut, you can see here m is 0. So this term will vanish, means it will become 0. So when it will become 0, this term will not be there in your LZ operator situation when you are operating it on sign, right? So it will not be there, the first term. The other two will be there. So it cannot be the eigenfunction of LZ. Okay. So when it is not the eigenfunction of LZ, you are just simply going to get the option C to be correct, because the given wave function is the eigenfunction of H and L square, and that's going to give you the right answer for this question. So that's how you are just going to get your option C to be correct for this particular situation. And you got to know how to work on any such type of questions and what are the steps you have to take. So that's what you have to take care of. Okay, one more. Let's take this one. Given the usual canonical commutation okay relations the commutator, which is going to be A comma B of A, which is equal to I xpy minus ypx, and B, which is going to be ypz plus zpy, right? Yes. Options are h cut xpz minus pxz minus h cut xpz minus pxz. Option C is h cut xpz plus pxz minus h squared xpz plus pxz. Okay, now in this case, what will happen? In this case, you are going to have a and b as the operators given to you, right? And if you will find their commutator bracket, now it's quite easy to find commutator bracket if somebody knows the formula to find the commutator bracket. But the question is how to find it easily, right? Because we will have two terms in the A, two terms in the B, separate two terms. And then we are just going to find the commutator bracket of A with B, and even the multiplied terms are there. So it can be quite time taking if you go with the detailed approach of finding the commutator bracket. So question is how to do this thing easily, right? That's what we are going to observe now. Look at this. The commutator bracket of A with B, to show the operators, I can take a cap on top. Okay, so even here we can just make the cap here, above every term. But since we all, those who are going to work on this question, we all know we are dealing with the operators in in case of commutator bracket or in quantum mechanics. So you will be considering that everywhere, wherever we are considering these ones, we are talking about the operators. Okay, that's what you need to know. Now let's go ahead to consider the next step. So let me just write it completely on the next slide. What is A, what is B, and then I will tell you the easiest way to work on any such type of questions. So I x cap y p y cap minus y cap p x cap comma y cap p z cap plus z cap p y cap. Okay, now in this case, what will happen? In this case, you have to just follow the steps the way how we are going to discuss, and just focus on what I'm going to let you know, so that it will be quite easy for you. So initially, to make it quite easy, I'm going to split them in the separate commutator brackets, and then we will go over the next step. So this is the first one, the first of the first part and the first of the second part, right? Then plus first of the first part and the second term of the second part. Like you just generally do the pairing of these terms, and you are just going to simplify them. Minus I cap, just simply iota, y p x comma y p z, right? Minus I y p x comma z p y, right? This is what you have to consider. Now next thing, what next? It is just simplification we have done. So now you have to see the pairing. What I mean by pairing, x with y commutator bracket, what it will be. So it is going to give you x with y commutator bracket will be what? 0. And x with z, pz will be 0. What about py with y? It is non-zero, and that is negative iota h cut. Okay, so is there any other pair we can form and we can have the non-zero value? The answer is no. So what I will do, if I have the product terms like the multiplied terms xpy and ypz, I have to see which one is on left side and which one is on the right side of the product. So x is on the left hand side and pz is on the right hand side, except the two terms which are giving us some non-zero value of the commutator. The other terms we are just observing. So the commutator bracket was giving us negative iota h cut, and the other we had is the p. What is that? Not py, it is just x. So because x was remaining, x was not giving us anything, right? So x cap, and the pz is on the right hand side, so pz here. Let's go on the second commutator bracket, x with z 0, py with py 0, x with py 0, py with z 0. Nothing you will get from here, so it's completely 0. Y with y 0, y with pz 0, px with y 0, px with pz 0, so nothing you will get from here as well. Y with z 0, y with py iota h cut. You got something from here. You can see how quick the process is. I was just explaining it to you. That's why it was taking quite a bit of time. But if you will be doing it on your own, you will not have to spend that much time then. Now, z is on the left hand side in the multiplied term and the px on the right hand side. So you are just going to get this as your final answer. Iota square is -1. So minus minus will become plus. So h get common xpz minus, no minus is there. It's plus zpx. That's it. Look at this. What is your right answer? Option C is the correct one. Is it so? Yeah. Option C is same as the terms we got and the sign we had. So option C will be your correct answer for this question. Tell me if in case there is anybody having any doubt, we can talk about it. But if everything is getting clear to everyone, that's great, great, great. And we are going to take the next question. So I hope that this easiest way of working on the questions based on commutator bracket and the other ones, that's getting clear to every one of you guys. And if in case is still, if you're going to have any doubt and you want to ask something, just let me know. I'll try to make it clear to you. Otherwise, I'm going to write the next question. Okay, next question's answer is important for you because if you will get some question based on this part, you can directly answer it with the help of the answer of this question. So that will be working as your trick. So here it is, and it says, give me a second. A particle is prepared in a simultaneous eigenstate okay, of L square and Lz if L times L plus 1 h cut square and mh cut are respectively the eigenvalues of L square and Lz, then the expectation value Lx square of the particle in this state satisfies options are Lx square expectation value is 0. Option B says Lx square expectation value lies between what and what? It's one is 0, okay, the lower value, and the other one is L square h cut square. Option C is 0 and Lx square expectation value L times L plus 1 h cut square divided by 2. Option D is Lx square expectation value lies between L h cut square divided by 2 L times L plus 1 h cut square divided by 2, right? So now the answer of this question, as we were talking about this part, can help you to work on the questions quite easily. So what is that part? A particle is prepared in a simultaneous eigenstate of L square and Lz if L times L plus 1 h cut square and m h cut are respectively the eigenvalues of L square and Lz, then the expectation value of Lx square of the particle in this state satisfies which of the conditions? Okay, so the right answer or the expression for the minimum and the maximum value for Lx square's expectation value is given in option D. So that's the right answer. If any time they are just going to give you a numerical based on it and they ask like, okay, what can be its minimum value or what can be its maximum value? So you can directly answer like, okay, it will be L h square over 2 as a minimum value, or L times L plus 1 h square over 2 as its maximum value you will have, right? So this will be easy for you to answer, and this is how you can just simply get the answer for this type of question. So that's how it can work as a trick, and you need to know that, and it is very, very, very much important. Now right now we are taking the questions from the quantum mechanics part, while we are going to switch to the other subjects soon, and we will be including the discussion for the other subjects as well. It's not just going to be about quantum, but also other subjects discussion will be here in this session as well. So let me just take few more questions from quantum mechanics and then we can go for the next subject discussion. Let me just see if I can add few more from the trick part right now. Okay, it's here, guys. It's here. Another one with a trick. We will be answering it. Consider the two lowest normalized energy eigenfunctions psi naught x and psi 1 x of a one-dimensional system they satisfy psi naught x is equal to psi naught star x, which is complex conjugate and transpose psi 1 x is equal to alpha d psi naught over dx, where alpha is a real constant. The expectation value of the momentum operator in the state psi 1 is. Options are minus h square over alpha square. The next one is 0, then h square over alpha square, and then next one we are going to have is 2h square over alpha square, right? Now, in this case, what will happen? If we are going to talk about this one, it's going to show you that it is the real function, right? Because it's A star means the complex conjugate and the transpose is equal to the wave function itself, right? So it shows it's a real wave function. Once you got to know, okay, psi naught is a real wave function, what about the psi 1? Psi 1 is a function of psi naught, as you can see here. So this alpha is a real constant. Other than that, d psi naught over dx is written. So when you know psi naught is real, alpha is real, so psi 1 will also be real, right? In that situation, if you have to find the expectation value of the momentum operator psi 1, so what it will be? It will be 0. That's how you are going to get like option B is the correct option for you. And remember that the expectation value of the momentum operator for any real wave function or corresponding to any real wave function is what? It's going to be 0. This is how your option B is the correct option. Let me know still if there is anybody having any doubt. We will be considering that part. But if everything is getting clear, we can take the next question then. Okay, next one. Just something which can be helpful for most of you, and here is the slide having the information about the latest offer which is going on. So if anybody is there who wants to attend the regular live sessions of well structured and well planned courses by the top educators we are having on Unacademy, and you don't want to miss these important courses in the classes by the top educators, then you can take the subscription and use and apply the referral code that is Anjali A Live as mentioned here on the screen. By using and by applying this code, you will be able to grab this offer and you will be getting the discount in the total subscription amount. So I hope it's gonna be helpful. Okay, now let's consider the next question where I'm going to include more tricks. Give me a second. And tricks basically means like something which can help you to solve the questions quite easily in very simple way, and you're not going to spend too much time to work on it. It makes the things simple, easy, and easy to manage for you. So our next question is, let X denote the position operator and P the canonically conjugate momentum operator of a particle. The commutator one over 2m p square plus beta x square, comma 1 over m p square plus gamma x square, where beta and gamma are constants is 0 if options are gamma is equal to beta, gamma is equal to 2 beta, gamma is equal to square root 2 beta, and 2 gamma is equal to beta. Try it now and let me know as you will get it done. So here, what is the trick and what is that important point I want you to know, which can help many of you to make it easy for you to work on such type of questions. Now, what is that point? That is simply going to be that if you are having a commutator bracket, which is just going to be about the position and the momentum operators, like here in this situation x and p are present and there is no other operator, like no angular momentum, nothing like a different one, right? So just position and momentum operators. In that situation, here we don't have so many terms in the commutator bracket, but anytime we can also have the many terms present in the commutator bracket. So this trick can help you in that situation a lot. So what you can do, you need to know that the commutator bracket of two operators, for example a and b you are taking, that will be equal to iota h squared times the Poisson bracket of those two operators. Okay, now so basically you are not going to mention the cap there, because now when you are going to consider the Poisson bracket, you can just simply write it and it will even give you the final answer. So I'm going to write it again, iota h squared the Poisson bracket of a with, oh, I have taken that cap on top of it again. Let me just write it again. So guys, this can give you the easy expression, as well as since sometimes it's going to be quite easy to deal with the Poisson bracket, then the commutator bracket, because you don't have to take care of those operator parts, the sequence and all. So this can be quite simple and easy. So you can convert it to the Poisson bracket of A and B, right? But iota h squared will be multiplied with it. Since in this situation the value you will be equating with 0, so that iota h squared will go on the other side and will be, the other side will be remaining 0, so it's not going to affect, right? So this is how you're just going to consider it, and let me know if in case there is anybody having any doubt. When you will simplify it with the Poisson bracket or commutator bracket, anything you can use, whatever you find convenient. If you are the one who finds it easy to work on the let's say the which part, the commutator bracket part, you can go with that. If you find it easy to work with the Poisson bracket part, you can use that one. It's up to you. Okay, and the right answer you will get after working on this, it's option B, which is gamma is equal to 2 beta. With any one of them you will work on it, it will be giving you the same answer. Okay, so that's something important and will be helping you a lot. So let me know if you have any questions or queries. Now we can change the subject. Instead of taking the questions, more questions from quantum, let's consider them from the other subjects too, because so many questions we have taken from the quantum mechanics now. And it's time to switch the subject to the another one. So which one you want me to consider? Let's go for the condensed matter physics, and some of the points from the condensed matter physics I'll be including, and then we will switch the other subject. Okay, let's talk about a point which is related to the most common mistake anybody can make, and it's like a slight difference in this expression or the statement, and that can make a big difference in your answer. So let me just consider it right now so that I'll be able to show you what condition I'm talking about and what you have to take care of, so that you will not be making the similar kind of mistakes. So the question says the energy of an electron in a band as a function of its wave vector k is given by Ek is equal to E naught minus B cos kxa, cos kya, and cos kza. Okay, this is what we are going to have, where E naught, B, and A are constants. The effective mass of the electron near the bottom of the band is. Options are, I'm just going to mention them here on the left hand side. 2h squared square over 3ba square. H squared square over 3ba square. H squared square over 2ba square. Option D says h squared square over ba square. So if you will be working on this question, what you have to find the effective mass. So do you know the formula for effective mass? If you know it, that's great. If you don't know, I'm gonna just write it here. M star represents the effective mass. Its expression is h squared square over d2e over dk square, right? In this situation, if we will talk about near the bottom of the band, that is the main condition I wanted to talk about and I wanted to show you. So when they are talking about near the bottom of the band, means k is tending to 0, but it is not exactly equal to 0. That's the mistake anybody can make. If the statement says at the bottom of the band, so that means k is equal to 0. But when they are saying near the bottom of the band, it means k is tending to 0. That's what you need to know. Okay, and now accept this. Once you got to know that the effective mass of the electron near the bottom of the band they are talking about, that means k will be tending to 0, means k is small. And in that situation, I can replace the cos theta, which is cos kxa, with the 1 minus kxa square over 2, right? So this is what we can do. Same way here, what we can do, we are going to consider 1 minus kya square over 2. This is what we can consider. And here what we can do, 1 minus kza square over 2. This is what we can relate and we can take, right? So it will give us 3 minus kx square plus ky square plus kz square multiplied with a square over 2. So in that case, it will give you k square a square over 2, right? So 3 minus this. Now in this situation, what will happen? In this case, you are simply going to consider the d2e over dk square second order derivative you have to find. So first order derivative will give you 2 times the k and second order derivative will give you just 2. So and this will become 0, right? Because that's a constant. So in this case, you are going to have negative sign, 2a square over 2 cancelled out, and 1 negative is outside the bracket as well. So it will give you plus ba square over, just that's it. So that is going to give you same answer as given in option D, and that is your right answer too. So this is how you will be finding it. Okay, so what was the main point in this situation? When they are talking about near the bottom of the band, it doesn't mean k is equal to 0. It means k is tending to 0, and that says k is small. And when k is small, cos theta, where theta is including or having the k in it, can be taken as 1 minus theta square over 2. Okay, so this is something you have to consider. Now let's talk about the next part. So what is that next thing here? That's going to be the other question like we will be including, and we are gonna take, so that we have to, like, we will get to know about more things. We will get to know about how to make the things more simple and easy and get the answer quite easily for any such type of question. Now the next question is the dispersion relation for electrons in an FCC crystal is given in the tight binding approximation by epsilon k. This question is even going to provide you an idea about the next point or the other point, which can help you to make the things quite simple and easy, right? So the expression is cos kxa over 2 cos kya divided by 2 plus it's cos ky a divided by 2 and cos kz a divided by 2 plus cos kz a divided by 2 and cos kx a divided by 2, right? Now next thing, where a is the lattice constant and epsilon naught is a constant with the dimension of energy the x component of the velocity of the electron at pi by a 0 0 is. Options are minus 2 epsilon naught a over h squared, 2 epsilon naught a over h squared, minus 4 epsilon naught a over h squared, 4 epsilon naught a over h squared. Okay, this is what we are gonna have. Now in this situation, what you have to take care of, like, which can help you to get the answer in less time and can make the process quite simple and easy for you. So what is that? The dispersion relation of electrons in an FCC crystal is given in the tight binding approximation by this, right? So this is going to be your dispersion relation expression you are going to have, because it is the E versus K or epsilon K relation, right? Now, K is the wave vector there, where A is the lattice constant, epsilon naught is the constant with the dimension of energy, and the x component of velocity you have to find. So you know that for the group velocity, we are having d omega over dk as a formula. But here you have the energy given to you. So what you will do? So you need to know E is equal to h nu or epsilon is equal to h nu. When you multiply it, this is nu, okay? Now when you multiply it with 2 pi and divide by 2 pi, you get the h squared omega, because h over 2 pi is h squared and 2 pi nu is omega. Now, so from here omega is equal to E over h squared you got. So just plug in this value here, you will get 1 over h squared dE over dk, and this is how you got the group velocity, right? So you also had the E given to you, but what you have to do, you just need the x component of velocity. So instead of taking all the terms, all the kx, ky, kz, to save your time, just take the kx here. Take the point where they want you to find the group velocity or the velocity x component of velocity, because all other terms are 0, so you're just going to get your answer this way. And when you will be doing that differentiation, you will just be doing the differentiation of the terms containing kx and kx. That's it. Rest you don't have to worry about, because this process can help you to save your time and to get the answer quickly and easily. So this is one of the ways how you can smartly work in the question on the questions in your question paper, right? So this is something important for everyone to keep in mind and to know, like, yeah, this can be done. Even there are more expressions in condensed matter physics, which we talk about and we consider in the discussion part of the questions and the concepts. So that is something we will be including in the discussion portion. Those are even the kind of tricks you can consider. But right now, the discussion which we are doing, mainly we are taking the questions and we are talking about what is the point or what is that thing which can make it easy for you to answer it and can make it quite simple process for you to reach to the final answer, right? That's what we are talking about. So now we are going to take the next question here and we will be observing that what is that trick which can make it easy for you to work on it. So next question I'm going to take is from the nuclear physics part, And let's see how many of you already know this trick. If you don't know, you will get to know now. So the question says the ground state of lead, that's Pb, nucleus has spin parity that is Jp, give me a second, Jp, which is equal to half negative I'm just gonna have a look at something. Okay, so Jp is equal to half negative, while the first excited state excuse me while the first excited state Jp is equal to 5 by 2 negative the ground state and the first excited state, 5 by 2 negative, this is 5. The electromagnetic radiation emitted when the nucleus makes a transition from the first excited state to the ground state. R, that's what you have to find, right? So the options are E2 and E3. Next one is M2 and E3, E2 and M3, M2 and M3. So in this situation, let me know what do you think will be the right answer, and do you know the trick? If you don't know, I'm gonna let you know. So actually one word you need to know to answer this type of question or similar to this one, and that trick is niyam. Like it's the name of your best friend or the new friend you are gonna make. So N for no here, Y for yes here. But yes or no for what? For parity. Okay, what is this parity we are talking about? This one, negative, negative. Is this parity change taking place? The answer is no, no parity change in these two. So then we have to follow after no, what are the two words or alphabets you are gonna have, right? And these are actually the words. I will be telling you what is the meaning of these two things present there, and if the answer will be yes, the parity change is taking place, so you will say okay, we have to follow these two. So when you're going to follow no, in this case it will be even electric. Okay, E for even and E for electric. E for even and for magnetic. That's what you have to consider, right? So in this situation, what will happen? So even electric and even magnetic. So is the parity change taking place? The answer is no. And then it must have the even electric. So even component of electric means it will be E2, E2. And what should be odd? Odd should be magnetic. So you can directly answer it. Odd magnetic only is there in one of the options you're gonna have. While if you go in the depth and detail that from where you got 2 and 3, because if they will change the options, instead of giving you 2 and 3, they will just add 1 as well in the options, then you can get confused that whether 1 will be existing there or no. So just to get sure about it, it's good to know the detailed approach. Detailed means the trick approach, but in a detailed manner. So what is that? That is, along with this, you also need to get the L values, which will be J1 minus J2 to J1 plus J2. Now, what is that? This is simply going to be, what is J1 here? That is any one of them you can take, because you are going to take the mod there. Okay, so mod will make it positive even if you are getting something negative. 5 by 2 minus 1 by 2, 4 by 2, which is 2, and 5 by 2 plus 1 by 2, which is 3. So 2 and 3. And since you know there is no parity change, so even component will be of electric. So E2. And what about the odd one? That will be for magnetic. So M3. E2 and M3 you got, right? So this is how you are just going to get your final answer. And that's your option C, which was the correct one. So in this situation, to get what is this, like whether 1, 2, 3 or just 2 and 3 you will have. So you are going to find the L values, and then depending on parity change part, you will get to know like even electric or even magnetic, what you have to consider, right? So that's how you're going to answer any such type of question, guys. Now we are going to take the next one. And if in case anywhere you will be having doubt, you can just simply mention it and let me know about it. We will try to discuss that point as well. But if everything is gonna get clear, that's great, great, great. So not just the detailed ones, I'll try to add some trick-based questions. So based on this, one more I can show you so that you can even try to work on it if you want. And it will be helping you to know how much you got that concept, how well you can apply it in the questions. A nucleus decays by the emission of a gamma ray from an excited state of spin parity to positive to the ground state with spin parity which is 0 positive. What is the type of the corresponding radiation? Options are magnetic dipole, electric quadrupole, electric dipole, and option D is magnetic quadrupole. So in this case, again, the first thing you have to check is the parity change. Is the parity change taking place? The answer is no. So even electric, the L is J1 minus J2 to J1 plus J2 within what? So that is just 2. So even electric means E2, right? Now here, why they have mentioned dipole and quadrupole and all. So what L value you get here, that is L now. So you are just going to take 2 the power L, which means 2 the power 2, which will give you 4 in this case, and that is quadrupole. So electric quadrupole is your right answer, which is option B. So depending on 2 the power L values, like you are gonna have 0, then it will give you 1, which is monopole. 1, which will give you 2, that is dipole. 2, that is going to give you 4, which is quadrupole. And 3, which is going to give you 8. So again, it keeps on going, and that's how mono, di, quad, octo, that's how you keep on getting them. If in case there is anybody still having any doubt, let me know. We will be trying to include that part, whatever is needed to make it clear. Otherwise, I'm going to give you the next question. A block of mass m attached to a spring oscillates horizontally on a surface, the coefficient of friction on a surface, then you have the coefficient of friction between the block and the surface is mu. Which of the following trajectories best describes the motion of the block? In the phasor space. XPX plane, and then it's a question mark. M and K, and the options which have been shown here are P, X and X. . px and x, and the direction is this one. Now let's talk about this part, that what you have to do if you are going to have any such type of question, and how you will be able to get the final answer for this type of question without making any mistake. So actually guys, in this case, what you have to consider, they have given a block of mass m which is attached to a spring, oscillates horizontally on a surface, right? The coefficient of friction between the block and the surface is mu, so that means frictional force is there, right? And the another thing is, which of the following trajectories best describes the motion of the block in the phase space? So that's what you have to consider. Now trajectory means what? The momentum versus position graph. So all the options are showing us that px versus x graph, right? In that case, what will happen? When you want to consider the best trajectory before going for this, because you don't have a potential expression in this case, they didn't give you whether you want to write it, so you can. But we are not going to go for that process. We are just going to observe, is it a conservative system or is it a non-conservative system? So in this situation, if you will see, it's a non-conservative system. Why? Because the energy of the system is not conserved. Why? Because if you will see, there is friction, so there can be some kind of loss of energy in the form of heat or any such factors can be there, right? So in that situation, we are going to have a non-conservative system. When it is a non-conservative system, in that situation, what will happen? You will have a trajectory which is going to be a kind of connected curves, and that is going to be something given in option A and option B. But what is the right answer? So here you can see in the option A, the distances keep on increasing as the arrow is outward, while in option B, it's going towards the center, it's decreasing. So the distance, because of the loss of energy, cannot keep on increasing, right? It will be decreasing slowly, and then it will come at rest. So in that situation, your option B is the most appropriate option, and that's the right answer for this question as well. This is how you will be getting it. Now, let me know if in this case, if you are going to have any doubt, we can talk about it. But if it is clear, that's great. I'm going to give you the next question now. So your next question is, again, all the questions, each and every question we have taken here, we have talked about, we will be discussing even now. Every question is related to your net and gate exams. Like, you get the similar kind of questions, you have to take care of these points, you have to consider that what we are going to include while thinking about the answer steps, the approach we will be taking and following. So everything will be helping you a lot to finalize your answers, to have great ideas about working on so many different type of questions. So this will surely be helping you. If the rank of n by n matrix A is m, okay, this is the rank they have given you, where m and n are positive integers, with m lying between, the minimum value can be 1, or it can be equal to 1 or less than 1, and n same, then the rank of the matrix A square is options are m minus 1, 2m, and the option D says m minus 2. Let me know what do you think is the right answer, and I'm gonna let you know the approach to work on it as well, because sometimes it happens that students are going to have the difficulty in considering the approach, getting the answer, and working on this type of questions. Like, what can be done? They are talking about n and m, okay? So if the rank of the an n by n order matrix, so they didn't mention that n is a particular number, they have given you the freedom that take n as any positive integer. So you can take it 2 by 2 order, 3 by 3 order. But for our convenience, instead of taking it as a larger number, we will take it as a smaller number, because that will be making the things easy for us to consider. So I'm going to assume it to be 2 by 2 order matrix. Okay, you are free. You can also take 3 by 3, 4 by 4, 5 by 5. And I'm going to go for 2 by 2 right now to show you the calculation and the steps. Excuse me. So it's going to be A as a matrix. I'm taking it as 1, 2, and here 1, here 3, let's say. I can even make it some other number. It's not necessary you have to make it same way. Now, what is the rank of the matrix? Firstly, you have to understand that part. So actually, the rank of the matrix is the order, like if it is n by n, so I will just say n. Okay, if its determinant is non-zero, or otherwise the square submatrices we have to check to know whether its determinant is 0 or non-zero. So if you will check the determinant of this matrix, that's going to be 3 1s are 3 minus 2, that's 1, which is non-zero. So its rank is what? 2, because it is a 2 by 2 order matrix, so n equal to n. Okay, same way I have to check the a square. So when I'm going to check the a square, what I will get, I'm going to have these as the elements of the matrix, and when I'm just going to simplify them, multiply 1 with 1, 2 with 1, that's going to be 1 1 is 1, 2 1 is 2. Okay, that's going to give you 3, then 2 and 6, that's going to give you 8, then 1 and 3, that's going to give you 4, then 2 and 9, 11, right? So now check out the determinant of this new matrix, which is for the a square. It will be 33 minus 32, right? Which is again going to be non-zero. Clear? So which means its rank is 2. So whatever we had the rank for the A matrix, same rank we are having for the A square matrix. So in the question they have given, okay, the rank of A matrix is M. So what will be for A square? It should be M as well. So this question we have taken just to talk about this part. If they have given us the generalized situation anytime, we are free to give it the values, define it, describe it, take some exactly like the kind of expressions which are possible to take. We can take it a particular case related thing, and then we can work on it, right? And it makes the things quite simple and easy for us to consider, to solve and simplify. Still, if anybody is there having any doubt, just mention it. We will be talking about that. And if everything is clear, we are ready to take the next question. And all these questions as discussed are related to your NET and GATE exam, as well as related to the easiest possible ways you can take or follow to get the answer for similar kind of questions. So it will surely be making the things quite simple and easy for you. Let me just take the next one. Okay. We will be including a few more questions here, okay, before ending this session. This one is also based on a trick. Let's go for this. A particle of mass m moves in a one dimension in the potential Vx is equal to kx to the power 4, where k is greater than 0 at time t is equal to 0. The particle starts from rest at x is equal to a. For bounded motion, the time period of its motion is Options are proportional to a to the power negative half, option B is proportional to A inverse, option C is independent of A, and option D says not well defined. So this time I'm going to give you some time. If you think you can work on it and you know what you have to do, you can work on it and give me the right answer. Otherwise, even along with when you are working on that, I'm going to start the discussion too. So actually guys, in this case, they have given you the potential and they are asking you to consider the time period of its motion, right? So it's not related to pendulum. It's not related to the normal expressions. You can work on it that way. No, it is going to be when potential is given and you want to find the dependency on x is equal to a, right? So the approach we follow in this situation is that we find the action angle variable, which is j. J is equal to integration p dq. Now p is equal to square root 2 me minus v, right? Now in this case, we don't do this complete integration completely. We just try to take a trick approach. Now what is that? That is j is proportional to square root 2me from this part. So I'm just going to write e to the power half from there because I don't need that 2m part as well. I just need the dependency on e. The reason behind it is that because t is delta j over delta e, so I will not need the constants. I just want to get the dependency or the proportional part, right? Now, other than this, you also have to get the value of x from here because we will be assuming that at x is equal to b or any other point is there where total energy and the potential energy both will be equal to each other. So when you equate them and you take like, okay, let's say at x is equal to b or d or w or u, okay, anything. So you are going to have the potential energy is equal to the total energy. So you put that value of x, then you take e here, e over k to the power 1 by 4. So from there you get the dependency e to the power 1 by 4, right? Now it gives you the overall dependency as 3 by 4, and when you got it, what you have to do, because the powers will get add when you are just gonna have the base same for those powers, so you can simply add the powers if the terms are in multiplication. So when you are going to differentiate it with respect to e, it will give you 4 by 3 e to the power 3 by 4 minus 1, 3 by 4 e to the power 3 by 4 minus 1, which is minus 1 by 4. So that's going to give you the e value. The time period depends on e as minus 1 by 4. But if you're going to plug in the e there, that is kx to the power 4 or ka to the power 4. So in that case, a to the power negative 1 you will get because you are going to plug in the value of energy here, okay? And that point here, we are going to consider x is equal to a because they have mentioned it. So after taking that value here, it becomes the value of energy, which is ka to the power 4. And this is how a to the power negative 1 is the dependency for the time period. And that's giving you option B to be the correct one. Tell me if in case there is anybody having any doubt, we can talk about it and we can consider that part. But if everybody is going to get it clearly, that's great. We are ready to take the next question. But if there is anything you want to ask related to this part, you can. I'm gonna have the another question with a trick as well. So let's include that here. That is the value of the definite integral. Which is integration 0 to pi d theta over 5 plus 4 cos theta is, options are 4 pi over 3, 2 pi over 3, pi, and next says pi by 3. So how, with the help of trick, this question can be solved within just seconds? Let's have a look at that. Anytime if you are having similar kind of expressions, depending on whether here is pi or 2 pi present, because in this case it's pi there, so I have to use the pi in my expression, but if it will be 0 to 2 pi, I will be using the 2 pi there. So what I'm going to do, I'm going to use pi divided by square root a square minus b square. What is a and b here now? So it is a plus b cos theta formula. So like not the formula, it's the expression, we call it a plus b cos theta. So when you're gonna see a is 5, b is 4, 5 square is 25, 4 square is 16, 25 minus 16 is 9, square root 9 is 3, so pi by 3 will be your right answer. That's option D, which is the correct one. Let me know if in case there was anybody having any doubt. Same way, if you will have the integration limits given to you as 0 to 2 pi, you will take the 2 pi here and you will be able to get the right answer that way. But right now, since the limits were 0 to pi, I'm going to take the pi there. Tell me if in case there is anybody having any doubt, we can consider it then. And if everything is clear, that's great, great, great. Next question is waiting for you guys. And we are ready to take the next question. If there is doubt, you can just mention it and let me know about it, okay? The Hamiltonian of a classical nonlinear one-dimensional oscillator is h is equal to 1 over 2 mp square plus lambda x to the power 4 is there. Now next thing, where lambda is greater than 0 is a constant. The specific heat of a collection of heat of a collection of no, I'm not going to write once again. Collection of an independent such oscillators is options are 3 n kb divided by 2, 3 n kb divided by 4, n kb and n kb divided by 2. Try it now and let me know as you will get it done, or otherwise I'm going to talk about it, that what you have to do in this situation. So actually guys, in this case they have given you Hamiltonian. Okay, great. What next? So they are asking you to find the specific heat capacity. Okay, that's too great. What next? The next thing is, since we know specific heat capacity, Cv is equal to du over dt or delta U over delta T or delta E over delta T, whatever you want to say, you can use the internal energy here or the total energy of the system. But how to find it? So actually in this situation, we are going to consider the average energy of the system. Okay, now why we talk about the average energy? If there is a system having the different states in it, and corresponding to those different states we are having the different energy values, then you can't talk about like just the one state energy or the total energy. Here we prefer to talk about the average energy. Means every state's average energy you will find, and that's how, like, not every state separately but by including all of them, and we are going to get the average energy that provides us the information about the total energy of the system, right? So same way here, to get the average energy, what is the thing you are going to use? We call it the equipartition theorem. which tells us that the energy associated with the each quadratic term present in the Hamiltonian is half kBt. So you can see here is the p square. Now you don't have to follow the m square because m is a constant, right? So you will not take any term for that. But for p and x in this situation, you are going to follow or focus on these two ones, and you are just going to write the terms for them. So the average energy of p square, like the each and every quadratic term present in the Hamiltonian, will be half kBt, right? So for the p square, I will get half kBt energy. What about x to the power 4? I will not be taking the square of kBt. Why? Because that will be changing the dimension of energy. So for this, because I can write it as x square to the power 2 means again square. So for this half kBt energy we will have. For the other square, half square, which is 1 over 4 kBt we will be having. So when we will have 1 over 4 kBt plus half kBt, it is 3 by 4 kBt, right? So 3 by 4 kBt you got as your average energy or the total energy of the system. Once you got it, what next? You have to consider the next thing, which is a specific heat capacity. So for that you will be differentiating it with respect to T, and that will give you 3 by 4 kB. Because you had such independent oscillators, so you are just going to multiply it with n, and that's how you will be able to get your final answer. Let me know if in case there was any doubt. We can talk about it. Otherwise your option B is the correct option for this one. We'll be taking the next question too, guys. Wherever there is any point, like specific point you need to focus on and you need to know, that's what I'm going to include here. So I'm just going to have a look at that. Then what else we can take and consider. Okay, let's focus on this one because it can help you what next I'm gonna take. Okay, to prepare a concept and to even work on any such similar kind of questions quite simply and easily. This is the latest thing for you to know about. Okay, that the iconic subscription price has been dropped by 20%. So it will be helping you to save more, and you just have to use and apply the code Anjali A Live while taking the subscription to get the discount in the total subscription amount. Okay, so guys, even if any of your friends want to take the subscription, you can share this information with them too and let them know about it. This is how anybody will be able to save more and can start their preparation under the guidance of top educators. Let's go over the question now. And even in upcoming days, so many new courses and the classes by the top educators will be starting on Unacademy. So if anybody is going to take the subscription, use and apply the code Anjali A Live to grab this offer and to get the discount. Here is our next question. Excuse me. Okay guys, next question is the energy levels corresponding to the rotational motion of a molecule are E J is equal to B J times J plus 1 centimeter inverse, where J is equal to 0, 1, 2 and so on to, and B is a constant. pure rotational Raman transitions follow the selection rule delta J is equal to 0 and plus minus 2. When the molecule is irradiated the separation between the closest stalks and anti-stalks lines in centimeter inverse is. Options are 6B, 12B, 4B, 8B. Now, in this case, we are going to do the discussion which will be helping you to answer any such type of question or to just get the answer quickly, right? So first of all, it's talking about the Raman spectra, right? Raman transition or Raman spectra. So what will happen in this case? You need to know that we are going to have the Rayleigh line at the center, okay? Then on both sides, we will have two different lines, that is stalks and anti-stalks. So this is Rayleigh, or we also call it the excited lines, okay? Let me just draw it again. Okay, and the another one you are gonna have is the stalks, and the another one is anti-stalks lines, right? So the separation between Rayleigh and stalks, this is a stalk, this is anti-stalk. So it's going to be 6B between the Rayleigh to the first stalk line, and Rayleigh to the first anti-stalk line, it is also 6B. While first anti-stalk to the second anti-stalk, the separation will be just 4B, where B is the rotational constant. This is very important to know because it has been observed like mostly we get the questions from this section. This is also 4B, and further regularly you will keep on having 4B, 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 4B separation. But just between the Rayleigh and the first stalk, that is 6B separation. Rayleigh and the first anti-stalk, that is 6B separation. B is the rotational constant here. Its value will be in terms of moment of inertia, means that is in the denominator, but there is a complete expression, right? So what is the question? The question asked you to consider the separation between the closest stalk and anti-stalk line. So basically this is the stalk and this is the anti-stalk. So what is the separation between these two? That is going to be 12B. Okay, that's what you can consider, 12B. So in this situation, what will happen when you're going to consider 12B? You are having that as your final answer because that is the separation between the closest stalk and anti-stalk lines. So option B is the correct one for you. Let me know if in case there is anybody having any doubt, we can talk about it. But if everything is clear, that's great. We can take some more questions then. Tell me if there is anybody having any doubt, guys. We can talk about that one. Here is our next question. Otherwise, if you will be getting the answer, you can surely mention it in the comments that okay, this is the right option, or whatever answer you're gonna get, you can just let me know. Try. So this is the question related to metrics, guys. In this case, what is going to happen? In this case, you are going to have a matrix given to you, which is a 3 by 3 order matrix. Now what you have to do, you have to find like what is the eigenvalue of this matrix, what will be the eigenvalues. So here, if you will observe this matrix, you can clearly get like if you are multiplying the first row with B by A, you are getting the second row elements, all elements like 1 by 1, and corresponding to this, if you are multiplying it with C by A, you are getting the third row elements, and this one B by A second column elements if you're multiplying the first column with that, and same way if you're multiplying this first column with C by A, you are getting the third column elements. So in that situation, you can clearly observe it and get to know like, okay, this matrix is satisfying the condition that the every like you can write the elements of this matrix by multiplying the particular row and the particular column with the constant, right? So that means the other rows and the columns are the scalar multiple of a particular row and the particular column elements. And so for such kind of matrix, our eigenvalues are always going to be equal to the trace comma 0 comma 0. Now what I mean by trace, that is a square plus b square plus c square. So you don't have to go with the approach that is m minus lambda I is equal to 0 and then solve it. No, it's gonna be very much time taking if you go with that. But if you solve it with the trick, you are just getting option A to be the correct quickly. Okay, so in the exam, like you will be able to think about these approach, these things, what we are trying to include as a trick or some ideas I'm providing you when you have worked on them so many times, when you are aware of the fact like, oh yeah, this is something which can be considered, this is something which can be done, right? So then these things are gonna just be there when we need them, but for that sake we need to do the practice lots of practice and so many number of times. There is no such rule that if you practiced any question 3 times it's done. No, either you can do it 5 times, 10 times, 20 times, any number of times, right? So it has been observed like many students consider that they have completed the questions, let's say 5 times, and then they say like, okay, it's done 5 times, now I don't have to do it again. Or if somebody does it like, let's say for 2 times, then they consider, oh, it has been done 2 times, so I have already worked on it, why should I do it again, right? But the thing is, as many number of times as you can work on the questions and you will be working on them, you will be able to get your like have a better command on the concepts, and you will be able to get the concepts by relating them with the questions you will be solving in the exam quickly. You will not have to sit and think there is something which can work, there is something which can be used here. No, you will have that clear idea that way. So let me just give you the next question now. So the state of an electron in a hydrogen atom is it's 3. This is the in a measurement of Lz for the electron in this state. For the electron in this state, the result is recorded to be 0. Subsequently, a measurement of energy is performed. The probability that the result is E2, the energy of the N is equal to 2 state is. The probability that the result is E2, the energy of the N is equal to 2 state. Options are 1 by 2, 2 by 3, 1 by 3. Try it now and let me know as you will get it done. And if you don't know, I'm gonna just start the discussion about it, like what are the things you need to focus on, how you will be proceeding further to get the answer, what are the points you need to consider while working on any such type of question, like all that we will be considering right now. So the question says the state of an electron in a hydrogen atom is this, okay, this I state. Where NLM denotes common eigenstates of H, L square and Lz operators in the standard notation. In a measurement of Lz for the electron in this state, the result is recorded to be 0. Then subsequently, a measurement of energy is performed. Okay, firstly what they measured the Lz and the result is recorded to be Zero, only zero, nothing else, right? So you know how you will be measuring the LZ, MH cut, NLM, so MH cut. But this will not give us zero, but these two will be giving us zero, right? Subsequently, at the same time, we are going to measure the energy. Okay, measurement of energy is performed. We are not going to measure, no, your measurement of energy is performed. The probability that the result will be E2 in that case. What is the probability of getting this energy? Okay, the probability you have to find. So its coefficient is our favorable coefficient divided by the total square of the coefficients, 1 over 6 plus 1 over 3. 1 over 3 divided by, it's going to be 3 over 6, which is 1 over 2. So you will get 2 by 3 as your final answer. And you can see what is important in this question. That's the reason we have done the discussion about it. So the important thing in this question is that reading the question very carefully, focusing on each and every statement of the question, what they are trying to say, what they have mentioned, and if there is someone who will be focusing on the question statement in such a way that not missing anything, what they have mentioned there, you will surely be able to get the right answer. So as they firstly measured the LZ, we worked on that part. Then we considered like, okay, that third one is not giving us the energy, the LZ measurement 0. So we can't consider it. Then they have mentioned subsequently the measurement of energy will be done. Okay, so then we are just working on the first two terms, and that's how we are reaching to our final answer. So it gives us option C to be the correct one. Let me know if in case there is anybody having any doubt, we can surely talk about it. But if everything is getting clear to you guys, that's great. So we have taken so many questions in today's session, and we have worked on so many different approaches, like which can help you to get the answer quickly and easily, and how you are thinking about them, how you will be able to get the answer. But still, if there is anybody having any question, query, or doubt related to whatever we talked about today in the session, just mention it and let me know about it. We can talk about that part as well. And if everything is gonna be clear, we can keep it this much today in this session, guys. And you can tell me if in case there is anything you want to ask or any doubt is there, we will surely try to include it. Okay, so here we are gonna have the different questions. Even before this, we have taken so many other questions. So as in the starting of the sessions, I have told you about the latest offer, guys, and the price drop which has taken place for the Iconic subscription. So that is 20% price drop on Iconic subscription is there now. Okay, and what are the benefits you are getting? All benefits of Plus, live doubt solving, mentorship and interview guidance, hard copy of study material in the Iconic subscription you will also be getting. And even in upcoming days, so many new courses by the top educators will be starting on Unacademy. So if you don't want to miss these important courses and the classes by the top educators, and you want to take your preparation to the next level under the guidance of top educators with the important notes, okay, even guys, if any day you are not able to join the live session, then recordings of the sessions will also be available, so you can check out the recordings. And even if there is any of your friends, those who want to take the subscription, those who want to do the best preparation under the guidance of top educators, you can let them know about this. And you can even let them know about the referral code, that's Anjali A Live, as mentioned here on the screen, so that they will be able to grab the offer. And by using and by applying the code Anjali A Live, you will be getting the discount in the total subscription amount as well. Okay, so this is how everything will be helping you guys. Even let me just show you what are the benefits you will get if you will take the Unacademy Plus, Iconic or the Lite subscription. So all these different benefits have been shown here, which will be helping you to decide which subscription you want to take and which one you find more beneficial for you. And as in upcoming days, even so many new courses by the top educators will also be starting. So if you don't want to miss them, you can take the subscription now and start your preparation under the guidance of top educators. Okay, so everything will be helping you to take your preparation to a very good level. So if you don't want to miss it, you can go ahead to take the subscription and start attending the live classes, the regular live sessions of well-structured and well-planned courses by all the top educators we are having on Unacademy for your upcoming exam preparation. Thank you everyone for joining this session and for attending.